Mohga, and today we're going to be explaining the lesson of electric current. In this lesson, we're going to know how electric current is related to charge, what are ammeters, what's electrical conduction, and the difference between direct and alternating current. An electric current is the rate of flow of electric charge. It's also defined as the charge passing a point in a circuit per unit time. So when we're talking about charge, let me write it down. We say that current, which is I, as you recall from before, is the charge per time. We took that the charge is in coulomb and the time is in seconds. So current could be measured either in in amperes, or it could be measured in coulombs per second. So current flows when a circuit is formed, when a wire connects two oppositely charged terminals of a cell from positive terminal to negative terminals. So current goes from positive to negative. To measure current, we use an ammeter, and it has to be connected in series with the component being measured, not in parallel, okay? The ammeter can be digital with an electronic readout, or it could be analog with just a needle and a scale. Analog ammeters range from 0.1 to 1 amperes and 1 to 5 amperes, depending on how much current you're measuring for analog ammeters. So you need to always double check exactly where the marker is before an experiment to avoid zero error. And you need to make sure that you're looking perpendicularly to the scale to avoid parallax error. Digital ammeters can measure very small currents in milliampere or microampere, and they show the measured value as digits, which makes them more accurate. They're easy to use because they give you a specific value and they can display more precise values. However, digital displays may flicker back and forth between values, which makes your judgment not that accurate. So you should also check digital ammeters for zero errors before you start. Make sure it's exactly at zero. Electrical conduction in metals. The wires in an electric circuit are made of metals because they're good conductors of electric current. This means that they allow the current to flow. So in the wire, the current is a flow of negatively charged electrons that can move through a conductor or a conducting wire. Finally, the difference between direct and alternating current. Direct current is a steady current constantly flowing in the same direction in a circuit from positive to negative. The potential difference across a cell in a DC circuit travels in one direction only. Current travels from positive to negative terminal. The DC power supply has a fixed positive terminal and a fixed negative terminal. Electric cells, batteries produce direct current. Alternating current, however, has continuously changing current, which changes its direction back and forth. An alternating current power supply has two identical terminals that change from positive to negative and vice versa. That's why it's known as alternating. Here they travel from positive terminal also to negative terminal. So the current changes direction as the polarity of the terminal changes. So when the terminals change, it starts moving the other way around. The frequency of an alternating current is the number of times the current changes direction back and forth per second. Here is an example or a table to show you the exact difference as we've just said. That's all for today's lesson. I hope it was easy and there was no problem. Please let me know if you have any questions. Have a lovely day.